Hello, everyone. This is protecting your web applications against external threats using AWS WAF and AWS Shield Advanced. My name is Maritza Mills. I'll be one of the presenters today, along with Johan Lamprecht, who is here with me. And then also helping to take questions is Ashraf Souk, as well as Rohan Rezada. At the end of the presentation, we will leave time for questions, and you can enter those in the webinar at that time. So to take a look at what we're going to be talking about today, we're going to start with just a high-level introduction of what AWS application security is, what the current threat landscape is, and what are some of the different types of attacks or other types of exploits that you should be thinking about when you are protecting your web application. We'll also review best practices for DDoS resiliency, and then we'll learn how to use AWS Managed Rules for WAF to quickly set baseline protections for your application. We'll follow that up with best practices for Firewall Manager for scaling the application of security across multiple accounts. And then we'll look into how to stop bad bots with these AWS tools, as well as engaging the Shield response team. And we'll look at a case study specific to that. So let's take a look at an introduction to application security on AWS. So there are kind of three categories of common external threats. In a nutshell, denial of service, app vulnerabilities, and bad bots. So when we think about denial of service, what we're really concerned about here from the user perspective is the availability of your application. So these specific types of threats, and a few of them are listed below, such as SYN floods or reflection attacks. What they are trying to do is overwhelm your system so that other users cannot use your system. And this could be problematic in that maybe your system appears to be working correctly for one reason or another, but the users on the other end are experiencing an inability to access the things that they need to access. So maybe no data is being lost, but this is preventing the intentional use of your website, for example. Then there's things that are kind of more internal to the way that you've built your app. So with app vulnerabilities, you're going to want to think about, for example, the way that you're using database calls and retrieving information from databases and how you're exposing that to users. For example, there's a common exploit known as a SQL injection attack, which looks for the availability of different places in your application to insert their own SQL code that may be trying to retrieve information that it should not have authorized access to. A list of what you've seen here for app vulnerabilities, such as cross-site scripting or common vulnerabilities and exposures. Many of those things can be found also as part of the OWASP Top 10, which is the Open Web Application and Security Project, and it lists some of the 10 most common vulnerabilities that you might see for your apps. Finally, then there's kind of more sophisticated attacks in the form of bad bots. And so you can have both good and bad bots. Generally, you might see bots on your page that are crawlers. They might be scraping for content, but they could also be bad bots who maybe they're scraping your content in places where they're not supposed to be, or maybe they're accessing your web page too often, again, going back to possibly causing a denial of service attack. Or there could be bots who are simply just probing for different types of vulnerabilities in your application. We're going to talk about ways that you can prevent these bots from taking advantage of any kind of vulnerabilities. So the next step for application security is to make sure that your application is both available and responsive for your customers. So a few things that you're going to want is that uptime protection that we talked about. You're also going to want to make sure that you can scale on demand. So sometimes, there are things that you're concerned about that are related to attacks or vulnerabilities, like what we previously talked about. But a very natural course of growth for your website could just be that more users related to a specific event or related to the kind of the growth of your business put more pressure on your application. And so part of kind of securing and maintaining your app is making sure that you can scale to meet that demand. And there's no malicious intent in that. It's just a matter of growing appropriately for the user base. And then finally, compliance. You want to make sure that you're staying in compliance with any local laws and regulations. If you work in a particularly regulated field, you also want to make sure that you're taking the right steps to live by those compliance regulations as well. And so we'll talk about some frequent challenges that are associated with trying to secure your applications. One of those, for example, is integrating multiple services. So for each of the threats and vulnerabilities that I talked about, it could be app-specific exploits, it could be denial of service prevention, or even preventing bad bots. Oftentimes, you might find different highly specialized solutions for each one of those, and they might be very good at what they do, but then integrating those services so that they work together on your single application can pose some challenges. Additionally to that, it can also be a resource drain. So not only do you need resources just to serve your app, you may also have to deploy and maintain additional infrastructure, such as network appliances or sensors or host-based agents, so that they can correctly monitor your application. And what you might find with this is that kind of depending on your level of expertise or maturity in this area, you may find that internally your team lacks some of the expertise necessary to get started with these or to use them in an advanced way. And finally, some of these tools can be expensive. And so having an easier and kind of more intelligent, cost-effective solution for threat detection would help you prevent abuse and protect your infrastructure on AWS Cloud. And so we're going to look at a few of the tools that are available to you here at AWS to do just that. We'll take a look at AWS Shield Standard, AWS Web Application Firewall, AWS Shield and AWS Shield Advanced, as well as AWS Firewall Manager. So taking a deeper dive into that, AWS Shield Advanced is a managed threat protection service that allows you to easily configure defense, especially from denial of service attacks, without changing your application architecture. You get comprehensive protection against DDoS vectors, as well as near-time real event visibility and protection from economic types of exploits. So we'll dig in a little bit into the differences between AWS Shield Standard and AWS Shield Advanced. So for those of you who aren't familiar, AWS Shield Standard is available to every customer who creates an internet-facing web application by default. This will protect you from the majority of different types of denial of service attacks that are out there on the web today. However, some customers have more advanced needs. You might be a more specific target of a very sophisticated type of denial of service attack, or you may just experience them frequently enough, or have specific app-related concerns that you would like to have more advanced protection in this area. So for example, with Shield Standard, it's kind of a pre-configured protection. You don't have to do anything for it. With Shield Advanced, you can go a little bit further and have a point and protect wizard to identify additional specific resources that you want us to pay extra attention to. With Shield Standard, you do have detection and mitigation of different types of threats, but with Shield Advanced, you can get faster mitigation that is also customized to the types of attacks that your application might be more vulnerable to, either due to the nature of the architecture or to the nature of the business itself. And with this is included 24/7 access to a Shield response team. So for example, if you know that your business has particular spikes of traffic or is particularly vulnerable to certain types of denial of service attacks based on a particular event, it's an example of when you might want to reach out to the Shield response team ahead of time. With Shield Advanced, you also get the real-time metrics via CloudWatch. It can provide you attack diagnostics as well as a global threat environment dashboard and a quarterly security report. And then finally, economic protection. This comes in a few forms. So one of them is AWS WAF at no additional cost for protecting your applications at layer 7, as well as AWS Firewall Manager at no additional cost when you're managing AWS WAF and Shield protected resources. Finally, what you'll get is cost protection for scaling, so that if your resources need to scale and stay up, for example, in the event of a distributed denial of service attack, we offer cost protections there for Shield Advanced customers. And this is a list of the resources that you can currently protect with AWS Shield Advanced. Again, by default, any internet-facing web applications are protected with AWS Shield Standard, but you can also have that kind of point and protect additional protection, focused protection that you can apply to, say, an Elastic Load Balancer, an Amazon CloudFront distribution, an Amazon Route 53 record, or an AWS Global Accelerator. So moving on to AWS Web Application Firewall, or AWS WAF. With AWS WAF, you can use managed rules or managed rules from the AWS Marketplace to establish quick baseline protections for your application. You can then customize the security or your rules to your applications by building your own logic. You can monitor these rules and the traffic that is going through them using Amazon CloudWatch metrics or third-party integrations. And then finally, you can automate parts of your security and remediation using AWS Lambda-based security automation. So these are the different resources that you can protect with AWS WAF. Again, with Amazon CloudFront, if your application is hosted there, you can also use WAF in front of an application load balancer or an Amazon API gateway. The last service we'll take a look at is AWS Firewall Manager. AWS Firewall Manager is great for scaling out the application of that security across multiple accounts and multiple firewalls on AWS. So for example, with AWS Firewall Manager, you can simplify the management of rules across accounts and applications. You can also ensure compliance to any kind of mandatory rules across your organization in a centralized single pane of glass, as well as enable quick responses to attacks across all of your accounts. And so when we talked about the different services that AWS Firewall Manager supports, AWS Firewall Manager helps you manage AWS WAF, AWS Shield, as well as VPC security groups. And findings related to the use of AWS Firewall Manager are also sent to AWS Security Hub. And for the scope of this project or this particular presentation, we will focus on Firewall Manager as it relates to AWS WAF and AWS Shield. And so now I'm going to hand it over to Johan Lamprecht so that he can talk about the AWS attack landscape.
Thank you so much, Maritza. Okay, so since AWS has launched EC2, we've been subject to DDoS attacks and observed this towards our infrastructure. Over the years, as network interface packet rates and throughputs increased, we also observed larger attacks towards our infrastructure. In 2016, we observed around 800 gigabits per second attacks, and this was caused by the Mirai botnets. This almost doubled to just over 1,600 gigabits per second with the memcached attacks around 2018. And since then, as operators around the internet patch their servers for open memcache servers, this has reduced somewhat. In the first quarter 2020, we observed an attack in excess of 2 terabits per second, and we'll soon be blogging a little bit about that. If we look around recent trends in the attack landscape, you would notice in Q4 of 2019, we observed in excess of 400,000 DDoS attacks towards our AWS infrastructure. More than 99.97% of these attacks were auto-mitigated without engaging a human operator. If we look at large web attacks in layer 7 towards our infrastructure, the biggest attack that we've ever observed was around 20 million requests per second. This was the largest attack we've ever seen towards a Shield Advanced customer who was also using CloudFront and AWS WAF. These services gave our customer the scale and the tools to weather the attack in a way that would have been far more challenging in a region without managed services like CloudFront. AWS Shield Advanced customers get a published quarterly security report that we combine every quarter to tell our customers more about what we've observed over the past quarter towards our customers, and they can use this information to better protect their applications and improve their application security. Shield Advanced customers also get access to a global threat environment dashboard that gives you real-time visibility into the attack traffic that's observed towards AWS infrastructure over the past day or weeks. Now I want to talk a little bit more about architecting for best practices when we talk about DDoS resiliency. We publish a white paper for DDoS resiliency, and I would highly recommend you have a read through this white paper. We spend a lot of effort on keeping this up to date, and having best practice architecture is really the best way to protect your applications against DDoS attacks. In this white paper, we talk about the difference between different AWS services and how they can protect you against specific types of attack vectors. We draw a line between regional services and edge level services. So if you look at services that's in the AWS edge like Route 53 and CloudFront, you will notice that they have significant protection against all infrastructure layer attacks throughout the OSI layer into the application layer using AWS WAF. And they also give you a geographic advantage because we have such a large edge network that spans the whole globe in more than 200 locations across the globe. That means that attack traffic would be drawn to an edge location close to the attacker, which moves that away from where your real users end up on our infrastructure. And this gives you geographic protection on top of all the other known vectors. This is significantly better than having a regional resource like an elastic load balancer. So this is really important sort of note that I wanted to make in terms of distinguishing between edge services and regional services. You get a lot better protection in the edge than you do in a single region. So I want to quickly talk about a few different architectures that our customers typically use, and so how you can best protect these types of applications against DDoS when you architect. First of all, let's talk a bit about web applications. If you have a web application, it's highly recommended that you use AWS Route 53 and CloudFront in front of your web applications. Like I just said, CloudFront gives you a global footprint for your application, and this will draw attack traffic away from where your real users is landing on your infrastructure. CloudFront also has significant protection against any known infrastructure layer attacks. We use DDoS mitigation systems in front of CloudFront, and every single packet destined for the service will always be scrubbed for DDoS. This is different from regional services. You also get the benefit that you can enable AWS WAF inside of AWS CloudFront, and this gives you significant protection against any web layer or application layer attacks. AWS Route 53 is also a service that lives in the edge. Route 53 uses technologies like shuffle sharding, which promises not to let any single customer's hosted zone land on the same 4-name server as any other hosted zone. That means if any single customer gets a DDoS attack, that will not impact more than 2 of the name servers that we've assigned to you. And so your applications will remain healthy even during DDoS attacks to your customers or any other customer on this infrastructure. When we talk about latency sensitive applications, applications that run on TCP or UDP and is not web application using HTTP, you cannot use CloudFront for these specific application resources. And so we launch a service called Global Accelerator that also live in the edge. This service significantly improves network latency towards your application by keeping customers' traffic on top of the AWS backbone all the way to your application endpoints in a specific region. So you can deploy resources like EC2 instances or network load balancers using UDP or TCP listeners, and then place AWS Global Accelerator in front of that to privately carry the traffic for your customers across the AWS global backbone towards your protected resources. This improves latency by keeping that traffic inside of the Amazon backbone instead of it going over the internet, which is subject to internet weather. And we prioritize that traffic to guarantee you better throughput and latency. When you use network load balancers, it is important to always try to enable TLS inside of those load balancers. This will improve TCP connection termination, and so network load balancer will handle that TCP network termination. So in terms of SYN flood attacks towards your NRBs, our network load balancers will absorb that attack traffic for you instead of it being passed straight to your backend. When we talk about serverless applications, you can use Amazon API Gateway. API Gateway gives you the option to implement usage plans where you can set throttles on specific API keys, which can protect your backend resources. You can also configure them to be edge optimized, which means CloudFront is placed in front of these. And so then you get all the benefits of the infrastructure layer protection in CloudFront. You can also add AWS WAF to these resources. And then again, like I already explained, Route 53 is available for routing your requests towards these endpoints. When we talk about protecting hybrid cloud environments or your on-premise, it is possible to use AWS Shield Advanced to give you the significant protection that AWS Cloud provides to our cloud resources, even when you serve your applications from on-premise. You can do this in multiple different ways. First is by just placing, if it's web applications, by just placing CloudFront in front of your on-premise web application and pointing CloudFront's distribution towards your on-premise devices. In those devices, we recommend that you configure a firewall rule that only allows the source IP addresses of CloudFront to be able to talk to that resource, protecting it from anybody kind of bypassing your CloudFront distribution and going straight to the origin. It is also possible to route traffic through CloudFront towards a network or application load balancer inside of a VPC, and then backhaul that traffic through Transit Gateway or Direct Connect or VPN straight back to your on-premise resources. And this will keep your traffic private and encrypted all the way to your on-prem. And with that, I'm going to hand back to Maritza.
Take a look at different managed rules that are available from the AWS Marketplace as a start. So there are a number of different rules and feeds available from security experts and some of the partners that you see here on the right-hand side. This includes coverage of some of the, for example, top 10 web application vulnerabilities that we talked about earlier for the OWASP top 10. This also includes rules that can help with API protection, as well as protection from common vulnerabilities and exposures, as well as protection from bot signatures with the addition of an IP reputation list as well. You can find any of these in the AWS Marketplace and subscribe to them with your use of AWS WAF, and these are pay as you go. You can also choose, if you like, to use AWS managed rules for AWS WAF. And so this is a set of pre-configured rules that you can deploy on your application. It does cover common attack vectors and threats. It is curated and maintained by the threat research team here at AWS. And it is also influenced by the OWASP top 10 web application and security risks. These managed rules are available to all WAF customers at no additional charge. So to dig into that a little bit more, let's look at some of the available rule groups. They tend to fall into 3 specific categories. One could be what you think of as baseline protections. The others are more use case specific. And then finally, there are IP reputation lists that can be a little more specialized. With the baseline protections, you could think of this as being similar to, like say, the OWASP top 10. It's something that almost every application is going to want to think about. With the more use case specific rules, it might be related to the way that you built your application. So are you built on WordPress? Are you using PHP? Are you built on a Windows machine or a Linux machine? You'll have rules that are easy to identify that apply to your specific application. And then finally, with the IP reputation lists, not only do they provide intelligence about where the request originated from based on the source IP, the nature of that information can be very useful to help you, for example, identify bad bots. And those include rule groups such as the Amazon IP list or the anonymous IP list. We also want to review, if you're going to write custom rules, some of the recent changes that have been made to the WAF API. And we'll start talking about first the document-based rule writing that you can do in JSON. In this case, rules are tied down to your specific security policy, or in this case, a web ACL. These rules can be copied, pasted, or deleted without restriction, and they provide a top-down level overview. There are also shareable elements to those rules that could be used between different rules. For example, an IP set or a regex set is also available for you to share. When you are using a rule, we have added a new way of considering what are the limits of the types of rules that you can apply to a web ACL. And we did that with the introduction of the Web ACL Capacity Unit, or a WCU. This is a dimension that is used to calculate and control the operating resources that are used when you are processing your rules within a web ACL. By default, the max WCUs that you're allowed is 1,500. And to kind of think about, how that limit might apply to your usage of WAF, different types of rules have different levels of kind of computational complexity. So if you think about a geographic match or an IP set match, those generally consume very low WCU, so just one as indicated in the graph here, the chart here. For more complicated rules such as regular expression matches or cross-site scripting detection, you're going to see higher numbers from 25, maybe up to 40. And then when it comes to managed rules, that's just going to vary based on the nature of the managed feed, but you would be notified as to how many that is going to take up of the WCU limit that you have. The API updates also provided enhancements to rule expression schema. So for example, you now have the ability to create nested statements with and or logical operations, which means that your rules can be compounded together using these type of nesting operations. You also have now full CIDR range support for both IPv4 and IPv6, as well as the ability to chain multiple text transformations together. And this is very useful for making your rule processing more efficient. Instead of writing rules to try and capture the nature of how the request came in, you can do some sanitation ahead of time to make that rules processing easier. And so all of these enhancements are part of the new WAF API v2, and you can use those today. So now let's take a look at Firewall Manager and some best practices for using Firewall Manager. First, we'll start with why Firewall Manager. So what are some reasons that you would want to use Firewall Manager in your organization? One of the first reasons might be if you have a large number of accounts and resources. So what we find is that for many customers, as they scale the number of accounts or the number of different resources that are used as part of their application, it can be difficult to maintain the visibility and the central control that they would like to have. So Firewall Manager is a great tool to help with that. Additionally, if you have kind of a more dynamic environment where new applications are being created all the time, it might be difficult to ensure that each of those newly brought up applications are consistently protected on day one in a way that is meeting your compliance expectations and your central security expectations. Finally, if you are just looking for a central kind of organization-wide visibility into threats, again, this is across different types of firewalls for both WAF, Shield, and security groups on AWS. You have a single place to monitor and respond to any of those threats or security incidents across the platform. So here we'll describe kind of what kind of customers typically use FMS. So if the use cases alone aren't enough, you can also think about how you fit into these different categories. So typically what we see when we start talking about scaling up, customers with 5 or more AWS accounts are usually the type who come to FMS, citing the need to kind of scale that more effectively. Also customers who have central information security and compliance teams who want that single pane of glass view across all of their applications and resources, as well as customers who want to scale individual protections across several accounts and resources. And this is how AWS Firewall Manager helps with each of those. For a start, Firewall Manager offers the central management of firewall policies. It's integrated with AWS organizations so that you can set specific centralized policies, for example, in an administrative account, and enforce those policies down onto the individual accounts underneath. This allows you to configure baseline policies that we talked about. You can do this for WAF rules or VPC security groups, for example, from a central administrative account. And then what it allows you to do is then detect for non-compliance in the individual accounts underneath the admin account and then remediate. So for example, you can use a policy-based security group management to discover any resources that are not compliant with the baseline policy and then remediate any non-compliant policies. So let's look at a couple of the best practices for using Firewall Manager. So for example, you can use Firewall Manager to simplify your WAF rule management across several different accounts and resources. And what this means is that you'll have the ability to ensure that all of your resources comply with a mandatory set of baseline security policies automatically. So that's even as they're brought online. For example, if you wanted to make sure that all of your applications had an OWASP top 10 rule group to protect your PCI workloads, or if you wanted to deploy a bad IP reputation list to prevent bad actors from accessing your applications, you can ensure that these rules were applied to all customers. Apologies, to all accounts. You can also select from partner managed rules or AWS managed rules, and you can use either one of these with your application of Firewall Manager across WAF. And you can deploy these across all the different resources, application load balancers, API gateways, as well as CloudFront distributions. For the second best practice, you can get rapid response to internet attacks by easily securing all your accounts using Firewall Manager. So you can use Firewall Manager to enable Shield Advanced protections on all accounts very quickly within the context, for example, of your AWS organization. One of the benefits of the AWS Shield Advanced support is that you have access to the Shield response team. And so this access is automatically granted when you add those protections to your resources. As part of the Firewall Manager policy, all accounts under that particular policy will automatically be subscribed to Shield Advanced. And the Shield response team can help you analyze any suspicious activity and assist you in mitigating issues on those resources. There are a couple of prerequisites to using AWS Firewall Manager. So one of those is that it does require that your organization is making use of AWS organizations. And then you will also need to enable AWS config on all of your accounts. So once you've done that, if you want to get started with Firewall Manager, what you can do is start by setting the master AWS account. So on the Firewall Manager console or in the API, you want to identify the account that is going to be the master for the organization. And this is going to be the account that, for example, will set the baseline policies. You will then create an FMS policy and actions. So for example, in this case, you might want to create an AWS WAF, Shield, or security group policy, and then select the options associated with those policies to decide how you would like to auto-remediate that. You can then set the policy scope. In this case, what you would do is specify the accounts that are applied by the policy, and then the scope of the resources included in the policy. And one way that you can do that is with tags. And those tags can determine, which resources are in scope or out of scope automatically. Finally, you can create the policy, just verify that the scope is what you want it to be, and save. And then this creates the necessary FMS policy, for example, for security groups or for WAF rules, and automatically adds the config rules for monitoring any kind of drift. So let's take a little bit of a deeper dive into how to use, AWS or AWS tools and managed rules to mitigate bad bots. So there is some bot management or bot mitigation activity that is native to AWS WAF. For example, you can take advantage of AWS managed rules for AWS WAF, such as an Amazon IP reputation list or an anonymous proxy list to kind of detect what types of source IPs are typical of bad bots. You can also implement rate-based rules with WAF so that if a particular bot is causing a load on your system, you can choose to create rate-based rules to help alleviate that load. You can also use security automations to do things such as detect login attempts and what success ratio you think is a threshold for indicating that that might be a bot instead of a human that is logging in. You can then set up automations, for example, to automatically add, IPs to your IP reputation list on top of the managed rules that you're using. as well as set up, for example, honeypot scenarios to quarantine bad bots and add them to your list as well. You can also do this with partner solutions via marketplace rules. We talked about some of those earlier. The thing to keep in mind is just that bots can cause more sophisticated attacks on your application, and you're going to want to employ specific types of protections to mitigate those concerns. These are some of the options that you have with partners from the AWS Marketplace. We'll touch on a few of those. For example, Fortinet malicious bots, F5 bot protection rules, or Imperva IP reputation. We also have partner integrations, for example, with CloudFront and Lambda Edge. You can see those across the bottom of the screen, such as Datadome, Imperva, Sequence, for example. And so for partner integration for bot management, what you can do is if you have your application applied on a CloudFront distribution, you then have that sitting in front of your application load balancer, and you can integrate the partner rules to actually protect your application from those different types of bot attacks or bot concerns. The partner bot integration, for example, can use Lambda Edge, not only to enable fast response without causing latency, but also to give you protection at the edge before the bot even hits your CDN edge nodes to access your applications. And so now I'll hand it back over to Johan to talk about how to engage the Shield response team.
Thank you, Marita. Yeah, so once you've signed up for Shield Advanced and you want to talk to the DDoS response team, once you have some application impact or you're under attack right now, so let me quickly go through how that engagement would go. So typically, if you're an AWS support customer, you'll open a support case, you'll specify AWS Shield service, a little bit of a description about like what resources are targeted right now, what's impacted, what is the impact, sort of red, amber, green, to your application right now. And then you select the highest possible severity based on the support contract that you've purchased with premium support. So for enterprise, that'll be a 15-minute SLA. For business support, that'll be 1 hour, and so forth. So this type of engagement would require or is dependent on the SLA of premium support. And so typically this process would go something like you create the support case and you wait for premium support to engage. And once that's happened, there might be some delay before that case is passed off to the Shield response team. Basically, there's this way and then a second way, which I'm going to cover right now, which will get you faster response from our team. So let me start off by giving you a quick checklist of the best practices when starting out with Shield Advanced. So first of all, it's really important that you specify the resources to protect. So once you've signed up for Shield Advanced, you still need to go into the Shield console and specify the specific applications and resources that you want to list as protected resources. As soon as you do that, you'll start getting metrics from the Shield console, and we will actually let you know when we detect an attack destined to any of these resources. We'll also vend you CloudWatch metrics that tell you about the size and the vector types of these attacks, and they will appear on your Shield incident dashboard so that you can triage these at a later stage. When you set up these protections, we auto create a CloudWatch alarm for you. You can then integrate your CloudWatch alarms into third-party applications like Slack or PagerDuty so that your on-call rotation or operational teams can get notified once we've made a detection. We highly recommend that you add rate-based rules for any WAF-capable resource. So if you have an application load balancer, an API gateway, or a CloudFront distribution listed as a protected resource for Shield Advanced, we recommend that you enable AWS WAF. It comes for free at no additional charge. And once you've done that, also enable a rate-based rule. This is the single most effective tool at blocking high request rate senders. So in terms of application layer attacks, a single source IP address can generate very high request floods. I often see escalations to our Shield response team where customers see single source IP address rate send request rates at at very high rates, more than 1,000 per second or more than 10,000 per second for single source IP address. If you configure a rate-based rule in AWS WAF, it would auto mitigate these types of attacks within a minute of the first request starting. Then you should authorize the Shield response team access to your APIs and Amazon S3 log buckets for AWS WAF. What will happen is during an escalation, we will be able to access these S3 log buckets. We have some tooling that can parse your WAF logs, and we can assist you with building WAF rules if this is already granted. It often happens that we see escalations where a customer hasn't granted this type of access, and then it extends or delays the time to mitigation. We will first need to enable this type of access, and then we'll be able to assist you with actually protecting your applications. We recommend that you enable logging for AWS WAF. If you have WAF logs, it gives you the ability to have insight into your web traffic so that you can craft better WAF rules to react to bad traffic patterns towards your web applications. And you can be very specific at crafting rules that only allow the traffic that you expect for your web application. Then we have something called the Shield Engagement Lambda. You'll see a link at the bottom of this page. This is a Lambda function that we create, which you can trigger whenever you're under attack. And the next slide, I'm going to explain to you kind of what that does. It directly lets you engage the Shield response team, bypassing premium support, so that you get faster response from the Shield team. So escalating to the Shield response team, like I quickly explained in the previous slide, you grant access to AWS Shield and WAF resources. This you can do in the Shield console. You just click grant access. It auto creates a service linked role that gives us access to your resources. Then you specify the S3 log buckets where you store your AWS WAF logs. And then once your application or when your application is under attack, you just trigger the Lambda function. What that will do is it automates the creation of a premium support case. And at the very same time, it pages an engineer in my team. We have an on-call rotation 24/7, 365 days a year. And one of the on-call engineers will immediately respond to that support case. We will generate an Amazon Chime bridge and respond on the premium support case with bridge details. And you can then immediately join that call, and we will remain on that call while we try and resolve your current impact. During that process, if it's a web layer attack, we might use our log parse fleet and point it to your S3 log bucket, ingest your logs, identify the attack traffic patterns, and help you build WAF rules to protect your application against the specific attack. Now I want to quickly just talk about some recent events. We've recently engaged a bunch of AWS managed security partners that can help you manage this undifferentiated heavy lifting. If you're a customer that doesn't want to spend the large amount of effort into configuring AWS Shield Advanced and AWS WAF, we have managed services partners that can assist you in doing that. That has a lot of expertise at designing edge-level security solutions on AWS. They're also great at reporting and giving you better visibility into your web application traffic. And if you're interested in this, here's an email address. You can just send us a mail and we'll be in contact with you. Now I want to talk a little bit about a case study, a recent engagement we had with a gaming customer that has Shield Advanced. So a little background. This customer was experiencing a DDoS attack. They have an application load balancer. The application load balancer started serving 500 error requests. This caused downtime for 3 portions of their web application, their game connection URL, their password reset portal, as well as their forum sites. After some investigation, they built some WAF rules to try and protect their application, but it still remained serving 500 error messages. So they decided to contact the Shield response team for assistance. When we got on a call with them, we realized that they never enabled logging for WAF. So we had to do a screen share with the customer to help them enable WAF. This took some time. So again, like, it's so important to have these sort of pre-steps correctly configured to save time during mitigation. At that time, The attack was still ongoing, which is unfortunate, but because it was still ongoing, we could get new fresh logs of the attack traffic. We were able to parse the logs for the specific attack, identify 4,000 suspicious IP addresses that had bot-like characteristics, and we built a custom IP set for that customer, installed it into the AWS WAF, and the customer chose to put it into block mode. At the same time, we also realized that most of the requests contained a special cookie, so we built a WAF rule to block any requests that didn't contain the specific cookie. We put it into count mode and realized that some post requests never contained this cookie, so we built another rule to avoid this false positive and enabled both those into block mode. Here are some metrics from the specific attack. You can see the spiky nature of the requests on this application load balancer, and then you can see at the very end, it kind of returns to something that looks near zero. Every spike that we see on here is actually attack traffic, and that near zero at the end is the customer's production web application traffic that they expect. If we have a look at the target response codes on application load balancer, you will see we were observing a lot of 500 errors. And as soon as we installed this IP set blacklist rule, that returned to 200s. And so this is an indication that the source network we identified here was really what was causing the application outage for this customer. And then if we look at the WAF metrics for the same load balancer, you will notice blocked requests. These are the orange spikes on the graph you can see over here. You will notice that we blocked a large amount of requests even before the IP set installation. This is WAF rate-based rules automatically blocking high request rate senders. But you would notice that there's also some blue lines below them, meaning some of the attack traffic actually passed AWS WAF. And so as soon as we installed the IP set and created the cookie block rules, you'll see that the spikes now completely flattened down. There was large additional attacks after that with no spike in allowed requests. So this shows you that an attack returned without having any impact on the customer application. And so at that stage, the attackers realized that it was no longer effective and gave up. So this is just an example of one of the engagements that we have on a daily basis with our Shield Advanced customers. And with that, let's move to the Q&A.
Awesome. Thank you very much for that, Johan, Maritza. So we got a bunch of questions from you, and thank you for very much for that. But before we go and take a couple of questions, I want to share with you two interesting, important resources that are available for you as white papers. So the first one that I really recommend is called AWS Best Practices for DDoS Resiliency. That talks about how you can use different AWS services to improve your security posture versus in face of DDoS attacks. And the other one is a very recent one that we released earlier this month. It is called Guidelines for Implementing AWS WAF. And it's a useful resource for anyone who's looking for implementing AWS WAF. And it is based on the most frequent questions and topics that we got from the field. Another thing before we move to the questions, this webinar is recorded and you will get the link to the recording afterwards. And if you have any additional questions, or if you have a project with regards to these perimeter protection services, please get in touch with your local account manager with AWS. Awesome. So I saw that there was a couple of questions on AWS managed rules. So let me ask them to you, Rohan. So one of them is how did we design AWS managed rules, or what we call AMR?
Yeah, thanks, Ashraf. So I think one of the things is the way AWS managed rules was designed was that it focused to provide some of the baseline and cover the most common and frequently occurring attack vectors. And one of the more important things here is that this is managed by the AWS threat team. And what they do is they routinely look for, scour the web for the popular attack vectors, and they are focused on mitigating those specific and the most significant threats. And the objective is to focus and cover those high severity attack vectors with a low false positive rate, given that the rules are one-to-many, they are shared and applicable to a lot of customers. And we receive a lot of feedback from the customers. We iterate based on that, as well as last but not the least is that we extensively use a lot of third-party vulnerability tools for sanity check and baselining.
Awesome. So you mentioned that we iterate based on customer feedback. Is there any frequency on which the rules are updated that we can share?
Yeah. So that's a good question as well. So as of now, there is no fixed cadence as to when the rules are updated. The way we operate, the threat research team, the way they think about putting these rules is they introduce new rules. Then those rules are put into a count mode or in general a monitoring mode. So it's not impacting any customer traffic. We are just observing how the rules are behaving, looking at the metrics. We have certain baseline against to compare it and see how it is affecting customers. Again, we are just looking at the metrics. Then accordingly, we change those rules and we have a change log on our documentation page as well for any changes that are being applied to the managed rules. And again, last is it's all based on the customer feedback, and we are listening to them and updating them as we hear more.
Awesome. So then, how customers should be thinking about AMR and their implementation?
Yeah. So that's again a very good question, and one I think which requires a little bit of thinking on your side as well. So one of the most common things which we get asked is that does AMR cover the OWASP top 10 rules? So one of the specific things is that it is the customer's application, and the way the web application firewall works, there has to be some mitigation which needs to be done at the application layer. So if you are running an application, you are using certain IAM policies. So you have to make sure, as an example here, that you are having only valid credentials, or the authorized users can only access your system. Similarly, another common OWASP top 10 feature is, for example, that if you are making sure you are using only the components with known vulnerabilities. And this means that as a customer, you are responsible for practicing safe coding practices, frequently patching your systems, and keeping software up to date. So the focus should only be that AMR is a solution which is a standalone solution. It is a mix of a shared responsibility. So it should be considered as a first layer of your defense strategy, but should not be your only strategy.
Got it. All right. Thank you very much for that. So, also with the release of WAF v2, this version of WAF that will get our updates and new features going forward, we got a question about whether the classic WAF will be ever decommissioned.
Yeah. So at the moment, no. We have no plan to decommission the classic WAF and the API, and we will continue to support it indefinitely. At the same time, that being said, we do recommend customers to migrate over to WAF v2 since all of the new features will be on the new API only.
Got it. And actually, recently we have released a migration tool that can help customers who are looking to migrate from the classic WAF to WAF v2, where we'll basically generate a cloud formation that includes the rule of your web ACL, and that you can implement as a WAF v2 instead of the classic version that you have already. Awesome. So another question that we got like in different ways is basically like whether Shield is available to this service or to that service. So Shield Standard is basically our DDoS protection that is available on AWS for any resources that is internet facing. However, Shield Advanced is available with a set of services. These list of services are explained in the public documentation. For example, it is available on global services like Route 53, Global Accelerator, and Amazon CloudFront that can work with Amazon CloudFront can work with any origin, whether it's on AWS, on-prem, or a different location, but also can be enabled on regional resources, such as ALBs, application load balancers, and elastic IPs. Awesome. So we're at the end of the time. Thank you very much for attending this this webinar. And again, if you have any question, you want to go further on a WAF project, please get in touch with your local account team, and we'll be happy to help you furthermore. Have a great day.